This is my coursework assignment on the effect of computing on nanobots. Usually when we think of computing, we think of it as an accessory to life, a tool that makes life easier. But what if it turns out that it could actually be a tool that saves lives? The hierarchy that I've chosen starts with medicine first and then subdivides into therapeutics, and from there on it further subdivides into nanomedibots. Nanomedibots translate into nanomedical robots. These are revolutionary in medicine because, as one study promised, in the first half of the 21st century, nanomedicine should eliminate virtually all common diseases of the 20th century and virtually all medical pain and suffering as well. Now let's get a peek into why this is. On your left, you can see chemotherapy, the usual method used in traditional medicine to kill cancer cells. But not only cancer cells, it also kills healthy cells. And this is where nanobots are revolutionary. Nanobots can be programmed to specifically kill only and only cancer cells. Now, I know that the picture here is very futuristic, but it is what this field is promising. Next question is, where are we currently? We are only at the very beginning. Currently, there are only patents, studies published. There are no legit robots on in the art of state. A patent published in 2016, for example, is a sensor molecular machine and controller added to a programmable nanorobot. This has got a sensor, a rotor, and a controller on it that can sense the environment around it and also establish communication with external devices. If a controller is installed on it, it can also make logical decisions. Now, how does it make logical decisions? Yes, this happens through coding. It is programmed. The code you see here in front of you uses C++ programming language. And this code is programmed on a nano camera to distinguish between objects using pseudocode for color tracking. Next question is, how far can we go? With reference to fiction stories and movies, there are no nanobots yet. One of the major challenges is controlling a molecule-sized machine to simultaneously perform a certain task. Some examples of projected advances of this field are a nanobot that identifies and kills cancer cells. This is done with a device that has a small computer on it and a supply of poison that is released when a cancer cell is detected. A second example is a permanent nanorobot installation. This is installed inside the tissues of a body, so that once this tissue is injured somehow, then this device could actually repair it once it's done. Lastly, gathering information from inside the body, which is very important. Imagine a nanorobot that goes inside your bloodstreams, gathering all information, all biological information from your body, and then us doctors or people being able to gather this information, analyze it, and analyze it. This could further medicine in ways we could have never imagined. Lastly, where do I stand from all this? I stand at the very foot of a mountain that's actually still being created. But a journey of 1,000 miles begins with a single step. And therefore, my steps are, for example, online courses, robotics, and coding. I should first start learning about on the big scale to then go to the smaller scale. Secondly, keep myself updated with news. It's really important to always be familiar with recent research papers, recent innovations, so that I know where the world is heading and I know where I should be heading as well. And lastly, to look for opportunities, because we shouldn't just sit still and wait for opportunities to rain on us. We should always look for opportunities, especially in such a yet emerging field. I want the change that I want to see happening, the change that I want to do is propose applicable ideas in the future to help advance this field a step or two, only a step or two. I know this is an emerging field, so I'm only opting for one step or two that will hopefully advance this field furthermore in the future. Thank you.